Without further ado, Paul, let me turn the program over to you. Paul Cianciolo, W1VLF.
Okay, Ed, thank you. Appreciate it. Yeah, I'm Paul Cianciolo, W1VLF. I live here in Northwest Connecticut. Started with amateur radio 2 or 3 years out of high school, and in 77, 79. So I enjoy all sorts of different aspects of it. But I wanted to make clear that I worked at the league, but I am not working there now. I have permission from Ed Hare to use a presentation that I made and delivered a number of times. I just want to make sure that nobody thinks that actually still there. The gentleman that's there, I can give you his information if you need to contact him for the official route. All right, so I named this "You're Not Your Father's RFI," and it sounds like a cliche, but really, it really is. If you think about, I mean, you look at all of us and you think, okay, well, you know, my dad fought in World War II, so okay, what kind of RF problems did he have as an amateur radio operator? Well, he had ignition noise, maybe some power line noise, right? A motor running somewhere or a welding shop, but not the kind of thing that we as amateur radio operators are subjected to today. So again, what was your father's RFI? Yeah, maybe some TV set, you know, RFI, welding shops, motor brushes, ignition noise, things like that. You don't see anything about switching power supplies here. And that's really, when you really come down to it, the crux of 80% of all the noises that are out there are either power line noise, switching power supply noise, solar panel noise, or grow lamps. Those are the ones that we really have to worry about. There's the old man while he was in the Philippines. I figured I named it after him. I better stick him in there. He'll be upset. So fundamentally, what is RFI interference? There's a source that's let's call it your power lines for now, right? And the victim, that's us, or anybody who wants to listen to radio that's not full of noise. Then the other way it goes is ham radio into televisions. But what this is trying to say is that basically this is a problem between two systems, and it's very, very easy for me or anyone to say, wow, all I want to do is my ham radio, and Ed over there, he bought a pair of some lights out of China or some other country, and now all I hear is noise, right? And not having a good relationship between the source and the victim, you know, you being the victim and the source being the person generating this, that's really a very hard thing to counter. The technical aspects of these things are not that hard, but the relationship are really difficult. And you'll see that more. 1988, Ed, this is my former boss, W1RFI. He started a database back in 2002. So that's what, 20 years in the making. And on file in those 20 years, we had 5,500 individual RFI cases that were documented. These don't include the calls. Hey, Paul, I'm having a problem. Do you know what it might be? Yeah. Okay. All right. Yeah. These are things that were documented and had emails going back and forth, and either had to have a letter written by the FCC or something. But these were more substantial. These were not just you're sitting around talking about it after coffee or whatever. These were all legitimate cases that were multiple emails and the countless other conversations in our handbooks. Okay. So let's thank the major players for all this noise, right? And here we are. Power line noise, LED lighting and grow lights and dimmers, and solar power is a big one. And I'll get into that a little bit because solar power is getting a really bad rap, and there are good systems and there are bad systems. Some of the other sources, plasma TVs, computers, routers, modems. I mentioned to the guys what I did here at my house. I have several routers and modems. They all run off 12 volts. Everyone had its own little plug-in switching power supply. And I got rid of all those power supplies, and I run one linear 12-volt supply. It feeds them all. And now I just got rid of 4 of those little wall warts. That's, that plug into the wall. Those are usually very, very pretty noisy. HVAC appliances, all the old days of having an induction motor are gone. They're all now 3-phase variable speed drive motors, in which now they have to create 3 phases and drive these motors. And so the drivers of the motors are, you can't buy a refrigerator or even a furnace now that doesn't have this variable speed, all in the name of efficiency. The AFCI, arc fault interrupters, those weren't so much noise problems. Those were ham radio operators would get on the air, and the AFCI, are you familiar with AFCIs? They're arc fault current circuit interrupters. And what happens is, in new construction, you have to have these in. And what it does is it's supposed to know if an arc occurs someplace in the system. It's got an algorithm that defines what an arc should look like from an RF perspective. And if there is an arc, it's going to break. It's going to, no matter how small, it's going to shut the power off to that area. It doesn't have to overheat. It doesn't have to blow the fuse. It shuts that off. Well, those are connected to this wonderful wiring system in our house, which is a really nice antenna, lots of wire, and RF from ham radio operators would get in there and cause those to false trigger all the time. Another one, this is one that I deal with here because I do a lot of listening down low in frequency, but even up to 160 meters, dog fences, the ones with the underground buried wire, they run fundamentally at 7 or 10.8 kilohertz, but they're chopped square waves, and they make a lot of noise. Harmonics all the way up into 160 meters if the one you have in your neighborhood is not filtered correctly. So hold the phone or hold the microphone. This right here, 50% of the time, the unknown source of noise is in the ham's own home. When I started working there, that was the general, people would say that, my boss would say that. I didn't believe it. But after working there and handling hundreds or thousands of cases, believe it or not, 50% of a new noise that's unknown, if you don't know where it's coming from, it's in your own home. So you have to power down your main breaker, run your radio off battery, and you can't just do it one breaker at a time, because you could have distributed noise sources in your home that, if you shut off one breaker at a time, will not allow the noise to completely go off. It'll still be generated by 2 or 3 places in your house. And you'll say, well, I did the circuit breaker test, right? You want to make sure that this noise isn't coming from your house. So you shut off the main breaker. That means you have to set the microwave and the alarm clocks and all that stuff. But once you do that, if that noise goes away, you've got a clean bill of health for your house. Now we can go looking elsewhere. And I've had that, like I said, 50% of the time, when a ham would call and say, hey, I got this source of noise. Have you ever seen anything like this? It's really hard by sound and by visualizations, movies, MP4s people would send. And it was hard to, usually the key thing is knowing where something is before what it is. Okay. And shutting off, your house is the main breaker is really the key to saying, okay, and making sure your UPS doesn't turn on and other things like that. So I was telling Ed about this. Okay, my mother, she's been gone now for a while, but she's had a 400 square foot retirement apartment. I was talking with her one day, and I looked around the room. I saw 7 switching power supplies on the wall, 3 in devices, 3 wall warts, 2 phones, 1 TV set, and a cable box. There was 13 or 14 possible sources of RFI in that one 400, 20 by 20 apartment. So in the complex, there was 300 apartments. So you can imagine how these things build up. That's why you have to shut off. Here's 13 possible items that could cause a problem in that one room. And if you don't shut off the main breaker to the house, you just shut one breaker off, another breaker off, you still have all these other ones that could be causing a problem. So That's really, really important. And this is kind of the RFI motto. And I said this to a million people. Where is it before what is it? So if Ed comes to me and says, hey, I got this RFI problem, and I go, oh, I know exactly what that is, Ed. It's this model LED Christmas lights, okay? It's the model ABC 1234. Now Ed has to go to every house on the street and ask everybody, do you have one of these? Or do you have this kind of it's bad enough that you have to go up to someone with your hat in hand and, say, I'm an amateur operator and I would, I think you have a noise coming from your house, but, can you imagine? So what we try to do is DF it, direction find where it is. And then once you do that, then you can do the power off test. But it is a little bit invasive if you have to go to your neighbor's house and say, Nomar, can you shut off all the power in your house? No, and maybe you don't have a good relationship with him. So that's the hard part. Where is this? Let's use direction finding techniques to find out where it is. Okay, it's coming from the neighbor's house. Now, at least I only need to go in there and speak with one person instead of saying, and I could tell you it's a LED light bulb. And then, first, even if I did give you that model number, do you think that the people who bought that LED light bulb have any idea what the model number of it is? So where before what is the way to go. And talked about this a little bit already, this diplomacy. These technical issues are one thing, but the interaction between people, some case examples, right? Ham would call in and say, I found out where the noise is coming from, and I went over and told that lady that she's violating the FCC 1, 2, 3, 4, 5, 6 rules, and over and over. And I told her that she's got to shut it down, or the FCC is coming to her house. Well, that's not. It's not like me walking over and say, "Hey Ed, I see you out there mowing the lawn. By any chance, do you have anything new? I'm an you see my antennas." And in the case of the guy who's demanding that she fix this problem, she's probably not liked his tower out there for the last 50 years, and now. And this is real honest to God cases. And now it's in her mind, this guy comes over and he's screaming at her. She's going, wow, I'm finally getting to get back at this guy a little bit. I've hated that tower for the last 30 years. So the diplomacy part of this is 80%, 20% is finding and fixing the problem. Because even if you know all of the technical solutions, if you don't have cooperation from the neighbor, it's not going to work. So don't start off on the wrong foot. You have this and the other here's another thing that's well, I bought these on at Walmart and it says FCC in the on it, and therefore you must have a problem with your stuff. Well, the FCC sticker is kind of abused by certain foreign countries, and they don't meet rules and regulations. So the ham thinks that, well, it's his problem. The lady whose house has the device, whatever it is, a humidifier, she thinks that, geez, I spent $75 on this and it has a sticker on it and it looks like it's working fine to me. I have no idea what you're talking about. You must have a problem yourself. So that's the diplomacy part. Can't really stress that enough. And that honestly was the hardest part of the job, was getting neighbor A and neighbor B to talk to each other and, hand holding and stuff like that. So please don't start off on the wrong foot. It only makes it more difficult as we go down the line. And someone named Jay Monroe made these pictures many moons ago. And I thought, geez, this is perfect, because this is what ends up happening from time to time. And here's one for you, Ed. He goes, here's a choke that'll fix the whole problem, right? So anyway, a little bit of so the FCC's definition of harmful interference. Okay. Now, what I think is harmful interference, what a hardcore VHF DXer who's looking for signals 2-3 dB above the noise floor thinks is, what the guy who's out in Maine somewhere on 100 acres thinks is harmful interference. Doesn't matter. The FCC has a classic definition, and it says interference which endangers the functioning of a radio navigation service. That's not us, so we don't care about that. Or other safety services. That's not us. Or seriously degrades, obstructs, or repeatedly interrupts a radio telecommunication service operating in accordance with the ITU regulations. That's us. Okay, but read this. Seriously degrades, obstructs, or repeatedly interrupts. So, for instance, if you have a carrier that comes up on 3929 and that's your that is your net frequency, you still have 2 more megahertz of that band to operate on. So the FCC doesn't look at these things like we do. A guy who is looking for, VHF long haul contacts that are out 300, 400, 500 miles, and he's got a big array on a tower and all. His idea of harmful interference doesn't fly with the FCC. So this is what, and so you have to prove this point, and that was something that was a little bit difficult. So here's how that works. The ARRL and the FCC have a cooperative agreement, and what the FCC said is, hey, ARRL, if you can take these complaints that we have, take your technical expertise, work with the hams, and try to get these resolved. And if we just don't get any cooperation, or you get no results from all the due diligence that you're doing down there in Newington at the league, and all the things are listed here, then, and try to work these out at a local level, then the FCC will write a letter to them that has more merit. For the first thing, let me see if we go up one here. Yeah, and the ARRL will, once we conclude that we know positively where the source is, there's no cooperation between the 2 neighbors, we pretty sure it's harmful interference, then ARRL will send a letter. Ed, this is Paul from W1VLF from the ARRL, and we're committed to helping amateur radio operators work with other folks to fix these problems. And sometimes that gets them to move, gets the offender to move. If not, after 60 days, I think the FCC will request that the FCC write a letter to the same people. Now it comes with a little bit of a hammer, a slightly bigger hammer. And but this isn't a guarantee that they're going to do anything either. And then 30 days after that, Laura Smith will send yet a second letter, and this whole thing takes months, not days. So working with your neighbor, even if you have to go over there with hat in hand, say, look, your Christmas lights are great. Can I buy you another set for $100? Is it worth $100? Is it worth $50 to try to get rid of the problems? Even though you're in the right, they're in the wrong, but compromise. Laura Smith, by the way, if anyone knows Riley Hollingsworth, she's the new special counsel. She's been there quite a while now at the FCC. Specifics. Okay, so let's look at Powerline Noise. Powerline Noise is, I hear a lot of people say, well, there's a transformer right outside of my house. Transformers typically don't make noise, but things that do make noise are arcing, loose corroded hardware. Even if a piece of hardware is in the field, you know why they call them transmission lines? Because they're transmission lines. And you put a piece of metal that's loose on a nut or a bowl up on one of the towers in the field that's between those transmission lines, it's going to arc, and that's the noise that you're hearing. Typically, power line noise is weather related. When it's cold and windy in the middle of winter and the poles are dry and shrunk up, the hardware loosens up and the wind is blowing, right after a rain, you'll go, holy cow, they must have fixed it. It's raining, and your power line noise is gone. That's not necessarily true, but as soon as it dries out, it'll start coming back again. Typically, wideband noise, okay, you're going to hear it on 160. It's going to be less on 80. It's going to be less on 40. And that's one of the ways that you tell where it's coming from. You get into mobile and you listen to it on 10 meters, and now you'll only hear it for maybe 100 feet. Or then you go up to 2 meters and 440. And you can define pretty well where it is. Harmonic energy is at 120 hertz. So I'll show you a spectral diagram. And don't bang the poles. That was a big one. People said, I went out there with a sledgehammer and I whacked the pole. One guy did that, and a cracked insulator broke and fell on him, and he was seriously injured. So this is an IC 7300. This is taking the audio out of your 7300 and putting it into a program called Audacity. I don't know how many people have heard of that, but there's a lot of programs out there that will do spectral like this. So let's see what this looks like. It looks like noise, pretty flat, right? I mean, it's relatively flat. Looks like an IF filter, the IF bandpass filter. Rolls off pretty quickly down by 100 hertz and rolls off again at 3,400 cycles. So this is like a 3 kilohertz, 4 kilohertz wide filter, and it's uniform. There's nothing there. But if you have line noise and you go into the plot portion of Audacity, look at these power spikes. There's one at 120 cycles. There's some other noise in here, right? Another one at 240, 360, 480, 600, blah, 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 all the way up the line. And they're not like, 128 hertz and 250. No, they're exactly on there. That's a really good indication that this is actual line noise. Okay, so all these harmonics. And the question always came up, well, how come 120 hertz apart? Why not 60 hertz apart? Well, if you think about the power line, it's an AC 60 cycles, and you have two peaks that go, you have a positive peak and a negative peak. And as this voltage is rising, at some point near the crest, it arcs. And then at some point near the negative crest, it arcs. So the end result is 120 hertz, 2 arcs per cycle or 120 cycles. So, but this is an important one. This is something anybody can do. You look at it and you see this 120, 240, 360, 480, you know that it's power line noise related. And at that point, there may be other things in there that are causing a problem. This is a really solid indicator. Leave the problem to the power company. You can find out where it is, DF it. Yeah, don't bang on the poles again. Any part is suspect. But when you DF this, you can use loops to DF this. You can use, we have right now in our possession the most powerful tool that you can imagine, and that's the little $149 SDR radio. Because now you don't have to go, I think it sounds the same, it looks the same. You can pull audio off, you can do spectral analysis. Huge amounts of clues can be determined by using that. You can also see real-time amplitudes as you turn the antenna, right? When you turn an antenna, like say a loop, and you're trying to find a null, the AGC is fighting you in the radio. It's saying, oh, the signal's getting weaker. I'm going to bring the noise up. So it's difficult. But with the spectrum analysis and the waterfall, you can see that carrier dipping right down very, very definitively. So that's a huge tool, and they're very inexpensive nowadays. Here's another one, LED and grow lights for orchids. Back then we were calling them orchids, but now just about every state is, marijuana is legal. So we're going in with the top 3 here in a row. This one is grow lights. And these were the toughest ones to fix. Not because they were hard technically to fix, but hard because there's a certain stigma attached to growing marijuana, and a guy doesn't want to go over, see, I think that house over there, they're growing marijuana in there, and I don't want to go accuse them of that, but there's a noise coming out of there. Don't know how to approach that. I had a number of people call and say, I think I know where the house is. All the windows are painted black. Should I go up the driveway? No, don't, you don't want to ever do anything that's unsafe. There's got to be a better way around it. So let's take a look at what do these things do? The light, they're high pressure lamps that need RF carrier between 20 and 100 kilohertz, and every manufacturer is different. So here's typically what you have. The AC power line, you have a big box, probably about this big, which is the switching power supply for these lights, and then a 50-foot cord that run to the lights. So on both sides, you have fantastic antennas, and they don't filter the harmonics out of these. I had a guy who had a grow house. This guy was in Alaska, had a grow house that was about 1.5 miles away. They had 10 kilowatts of light. And so you can imagine the noise that he had. Here's a clue. It'll be if the manufacturer decided that they were going to run their ballasts at 20 kilohertz, you're going to see 20, 40, 60, 80, 100, 200, like that all the way up. And then you would see it on say 3900, 3920, 3940, 3960, like that. And you'd very clearly see that with an SDR. With an old tuning radio that you tune manually, there's a lot of noise there, but you don't see those peaks, and it doesn't identify itself as well. The other thing about those is it's not weather related. It uses the power line and the internal wiring systems as the antennas. But here's a good clue right here, number where the mouse is, the dot number here. The typical complaint would be, I got this problem where I get the noise. It starts at 3 o'clock and goes off at 9 o'clock in the morning. Exactly 3 o'clock? Within a minute. I've looked at this for a couple of weeks now. Within a minute, and it goes off at 8 o'clock in the morning. And it's on 24 hours a day. Well, not that I know anything about growing marijuana, but what I've gleaned from this is in the very beginning, the plants can only tolerate so much light. And as they get more mature and they grow, they have a longer period that they can accept light. And then finally, they're running 24 hours, not too long before they harvest the material. Those were really tough. Most of the ballasts, the lighting systems that are bought on eBay, Amazon, are non-conforming with Part 15. And this is a real tough one because you don't want to accuse somebody of that. You just want to go and say, there's some kind of a noise coming out of your house. Have you put anything on lately? Do you have anything on a timer? And there's ways to fix this. There's ways to fix this after the fact, and there's ways to fix this in the manufacturing process. But it's like, let's say, got to pick on Ed again. Ed manufactures grow lights and grow light ballasts, right? And he does it by the book. He gets them tested by the FCC. Everything is fine. He's got certification. And I've been buying them by the ton, right? Like as I'm a distributor. And I say, hey, Ed, I'd like to continue buying yours, but these other guys are a lot cheaper. Can you lower the price a little bit? And Ed says, well, you know what? I can still make the light operate okay, but if I take off all the RFI components on the input and the output leads, I'll save $20 in components, and now I can sell them to you cheaper. And that's basically what happens. All the Chinese stuff comes in with no RFI mitigation whatsoever inside. So then you have to buy it and put it outside. This was a case that we worked on for quite a while. The power company comes up to Ed's liquor store. Ed's got a liquor store now and a marijuana farm. And he tells Ed, he says, look, I can save you tons of money. You've got 164-foot LEDs in there and 100 in your showroom and 60 in the warehouse. And I'll replace all those, because the power companies have incentives to cut down on electricity usage. And you'll have a return on investment in a year or so. And Ed says, holy cow, that sounds great. And it came from a reliable source, the power company. But your ham next door all of a sudden says you're causing interference. One ham is getting interference and Ed's running his store. Who do you think the FCC is going to, back in this? And they say FCC approved. Well, even if they are FCC approved, you put 160 of something that's FCC approved, and the noise is cumulative. It adds. So one might be no problem at all. 2 or 3 you might hear, but 160 of them, right? And the guy was living in a very, very close to an industrial zone or a commercial zone. So unfortunately, he had to live with it, and we had to work with him to use loops and RF phasing to get around the problem. And here's the other one: solar power voltaic systems. People say, I got solar panel noise, and that is absolutely untrue. You do have noise, but the solar panel does not make noise. The solar panel generates DC. Now I got to chop it and put it into the 60 cycle line, and I want to do that chopping efficiently. Okay, so when I'm trying to do that efficiently, what happens is I use square waves, sharp transitions, so I stay out of the linear portion of the device that's doing the switching. And guess what happens? It's sharp. Anytime you have a fast rise time, if you have too fast a rise time in CW, what happens? You get key clicks, right? If you have too fast a rise time here, you have all sorts of RFI is being generated. So in most solar panel systems, you have one of two things. You either have optimizers, or you have, there's lots of different configurations. If you're going to buy a solar panel system, buy end phase, okay? You don't want to buy a solar edge system. There's a thing called an optimizer. Fits on every single solar panel. I have 21 solar panels on my roof and 21 optimizers. And what the optimizer does from the solar panel is it constantly tries to extract the most power that it can. And so it's really a DC to DC converter, and it's got fast, sharp edges and harmonics. Let me just see if I can. This is the noise floor on 3910 on my house previous to them put Solar Edge coming and rectifying the situation for me. Okay, so if we go back here and you say there's these optimizers, as they're called, they have a fundamental operating frequency around 200 kilohertz. Okay, what's this? 3600, 3800, 4000. These are the switching noise from the optimizers. And it's all the way up to 20 meters, even up to 10 meters. You know, you're switching 300 watts, 300, 400 watts per panel. You're going to have a lot of harmonic energy. The rest of this at 18 kilohertz here, all the rest of this noise, this is from the inverter. Let's see, 200 kilohertz. Yeah, the other source is the actual inverter. The big wall-mounted line tie inverter. That's where that other noise is coming from. But if you had called me and said, my neighbor's got solar panels and I just can't use my ham radio 24 hours a day, well, right away, as soon as the sun goes down and there's no light on those panels, the solar system is quiet. That's just a known one. Okay, it's time of day, weather related, no light, no noise. It uses the wiring system, the actual wires that lead up to the panels. Those are wired typically in a loop. So you end up with a quad loop with 200 kilohertz driving into it. And, you know, you'll see that energy peak at the frequencies that loop is actually resonant on. So that they can be really noisy. Here is the issue. The FCC says, now Ed's making power supplies. Ed, you want to make power supplies? Do fantastic. But you can't put noise on the power line, okay? If you can meet these specifications, whatever you do in your box, that's fantastic, but you can't put noise on the power line. Okay, and Ed does that, right? And guess what? These solar panel systems, even the one I just showed you, pass FCC Part 15B because they do not put noise on the power line, but all those cables that run up to the panels that are on your roof, that are 30 or 60 feet long. 33 feet's a quarter wave on 40 meters, and 66 feet's a quarter wave on 80. And those are typical lengths for running these systems. So that's where all the noise is. It's not coming out the AC part of the inverter onto the line. So here's a great article if anybody wants to read it in QST. I think it was Tony Brock Fisher that wrote this. Can amateur radio and solar power coexist? 2016 systems were starting to get popular. Hams were starting to notice. And Tony did a really good job at mitigating the noise on his system. But it's not easy. So Enphase, on the other hand, is a different kind of a system. They have an inverter on every panel. So what comes out of the panel is AC that plugs into the power line. Now they're subject to the same rules that Ed is with his power supplies. So those have to be well filtered. These rules, the DC side of the FCC does not have rules that pertain to the DC side of solar panel systems. They should, but the manufacturers, they passed FCC rules, right? The rules are behind the times. So again, here's what it looks like. These 200 kilohertz carriers are gone, and the 18 kilohertz is significantly lower too. Switch mode power supplies. I mean, we're kind of talking about the same thing over and over here again. Solar panels have switch mode power supplies in them, or DC to DC converters. Any one of these things, it could cause noise. But the key is this. Again, Ed, only you could do whatever you want in your box, but don't let it get out onto the power line. Okay, so Ed puts in a line filter and common mode chokes, and he's got a perfectly clean power supply. Most of the time, these little switch mode power supplies don't have any filtering. And once you let that get onto the power line, now you've got all the wiring in your house and all the stuff up and down the street as an antenna. That's a real problem. And as I spoke a little bit earlier, electrically commutated motors. The push is on green energy, saving energy. Things like induction motors don't really exist anymore. They're all these electrically commutated motors, which means I have to build switching supplies to drive the motor on my furnace, the HVAC. I even had one where the guy, the ham called, and he had a good relationship with his neighbor, and he said, geez, it comes on for like 15 seconds and then it goes off, this noise. All different times of the day and night. I don't understand it. Well, it ended up being an on-demand water system. It didn't have a tank like we have up here, a hot, cold water tank. It had a pump, and the water, when you turn the water on, the pump would say, well, like a pressure washer, let's say. It would say, oh, the pressure went down in the system. I've got to turn on and run. And then as soon as you shut it off, it would go off. And so these faucets all over the house were going on and off whenever you needed water and making noise. So it's a jungle out there. Toroids. This is I worked in the cable industry for a while. This is a really old cable TV box from like the early 80s. But you get the point here. The point is that this box is making noise. Just like we were talking to Ed a little while ago about his power supply. Don't let that noise come out the power line and get onto the AC line. Here is the cable in, and this is the one going to the television, or vice versa. But you have to choke it off. You have to stop. Here's what I would say. I would say, you know what if I give you a kilowatt amplifier for 160, but only a 2-inch long antenna? How effective would you be in, DXing or transmitting? Not effective at all. This box, this cable box, or whatever the particular noise making machine is generating noise, and you have to cut the antennas off of it. Deprive it of any antenna. That means the power line could be an antenna over here. the going off to the television set could be an antenna over here, and so could this wire. So these chokes act as giant resistors at the offending frequencies, but don't do anything to the real frequencies that are going through. So terminate the RF before, ideally, this would all be built into the box, but a lot of times they don't do that. Here's a couple of chokes that I built for couple. I don't remember what these were, but there's common mode chokes, inline EMI filters. You guys have probably seen these. These will get rid of quite a bit. This is the part Ed took out when I asked him to cheap up his power supply a little bit. And snap-on ferrites. How many turns do you get in a snap-on ferrite? Typically, they're made about the same size as the coax cable. And the amount of choking impedance is a function of the square of the turns ratio. So let's say you have this core here on the left-hand side, and you place one turn of this cable through it. And let's say at the frequency that you're interested in, you get 10 ohms of choking impedance. It's not going to do anything. 2 turns will give you 40 ohms. 8 turns will give you 64 times that. So 6,400 ohms. So it's just one place in life where you get something for nothing. It's the square of the turns ratio. So that's why these aren't effective. All you get is 1 turn. You need thousands of ohms of choking impedance in the HF bands to be able to effectively, choke off any noise that's coming out of there. And here's different materials, right? So there is a number 75 material. See, they don't, the 77 is not in here. The 33 is not in here. I can get you a better chart, and I'll get it and send it to Ed that he can share. But look at this number 75 material. For a single turn, you would get here at, I don't know, let's say it's at 160. So it's like right here. You'd get 25 ohms of choking impedance, 25 ohms, right, of choking impedance. But if you bought a number 64 material, or you didn't know what it was, you would only get 2 ohms of choking impedance. So this 25 times 4 turns is 16 times as high. 16 times 1 ohm is still 16 ohms. So your dollar should be spent specifically where the problem, your area of interest is. And it's not uncommon to have one core to notch out all this stuff and another core to notch out all this stuff. So cores get to be, ferrite, toroid cores get to be a little bit complex. And this is the differential mode filter. Here's a noise source. Here's Ed's power supply. So 60 hertz comes through here, no problem. Does whatever it has to do in his power supply. And all this noise tries to come out. And what does this look like here? A low pass filter, right? Shorts the high frequency noise to ground, impedes it going this way, shorts it to ground again or across it. And then this also filters some of the other stuff out. And this would be the piece that would be taken out. You need this type of filtering in the device you're making. Once the energy makes it to here, it's out on your power line. It's out on all the cables in your house. So tools for locating RFI can be as simple as an AM radio with shortwave, right? The SDR is a spectacular tool because it allows you to see a waterfall. It allows you to get those relationships of, it's at 50 kilohertz, 100 kilohertz, every 50. It's at every 50 kilohertz. That gives you a positive ID when you go out into the field and start looking, trying to locate where this is coming from. You pull up in front of somebody's house and you hear a whole bunch of noise on your car radio, but it's not every 50 kilohertz. It's not the same noise that's killing you back home. So those are really powerful. Loops work really well for DFing because of a well-balanced loop has a nice figure 8 pattern. I think Don WB8 DSB did a flag antenna that he used very successfully for DFing powerline noise. But you have to use the appropriate tool too. Many hams bought the MFJ ultrasonic dish to try to find a noise problem. This is not your first tool, because at 30 feet away, this parabolic dish can tell you if a noise is within a 1 foot circle. And you don't know any direction where the noise is coming from. And it's only because Powerline arcs physically make ultrasonic noise that you can point at them. So you have to use the right tool. But go portable with a ham rig or the an SDR like the RTL dongles or AirSpy or SDR Play. I've got all three of those, and I've used those successfully. And a lot of guys have used those successfully to locate the RFI problems. These are near field loops. All it is a piece of coax cable. The center conductor is sticking out here and it's soldered. That's all it is. This one is like, if I connect this to a spectrum analyzer or an SDR, I can move this around the room and I can tell you that my monitor is causing this noise. Okay, that's good to know. But if I go to this one, which is only 1 inch in diameter, I can tell you within a 1/2 inch on the face of that monitor where the power supply is, right? So I wouldn't go all around the room with that 1 inch core, 1 inch loop looking for this noise, because it can only see, when it's extremely close. And it's the same way. You don't take a 1 foot or a 6 inch loop out into the world. You take something bigger than that you're confident in, and it has well-defined nulls. So what are you going to do if there's no resolution to the problem? You can, and not to toot my own horn, but you can go on YouTube and look under W1VLF, and you'll find a couple of videos that I did, 3 or 4, about noise and about loops and about nulling and about phasing. There's a couple of really good examples of daytime 75 meters with noise. It's really amazing what you can do with phasing down here at the TNC ANC4 noise canceling, but you have to have quality noise. So basically what this was what do you do if your neighbor won't compromise? You still want to be on the air. Well, it's up to you. You move your antenna to the other side of the yard, get some distance, or you bring in a noise antenna and phase out the noise that's causing the problem, or using a directional array like a K9AY, which is relatively small for receive. All these things are helpful. So 3-step problem. Identify the problem. That's different than locate it. Identify the problem. Maybe it has this particular every 50 kilohertz, or maybe it's every 120 hertz, like it would be in the case. Locate where the problem is by using that identity, and then you have to interface with the operator of that device. Consumer devices have to pass, in theory, FCC Part 15 rules. If you're going to plug it into the wall, it has to pass those rules. And that's where Ed took his device up to a lab, and they tested it, and they said, Ed, you're in great shape. You pass all the FCC rules. You've got all the proper EMI filtering in there on both sides. Fantastic. But it's the responsibility of the owner of the device, technically, to fix the problem. I'm a ham. My neighbor's got some kind of a device that's causing me harmful interference or just interference, to them to fix it. But you can't just say, you got to fix that damn thing, right? You can't, I mean, we have more technical knowledge than they do, and that's what we're trying, and it could even be a helpful situation. If you end up going through the FCC, it's a long, drawn-out process, let me tell you. Future threats. Electric vehicle charging. On its own is maybe not so bad, but inductive electric vehicle charging is where there's maybe a 2-foot square pad in your garage that is one part of a transformer. It's wound loop transformer, and then you drive the car over it. It's a couple inches. There's a couple inches gap, and the car communicates with that coil and starts drawing current from it. Typically at a 10 kilowatt level, if you're going to fill a 100 kilowatt battery, which is typical in some of the bigger electric vehicles, at 10 kilowatts, it's going to take you 10 hours. So there's a very high rate of current transfer there. That can be a real problem. And we're going in that direction, but I don't know. There's not many, at least where I live, there's not many. I'm a little bit further away, but some of the houses and hams that I had to deal with were literally, their roof lines were 7 feet away from each other. So if your neighbor's got one of these and your antenna's on top of your house, and so you've got 10 kilowatt RF generator 20 feet from your antenna, that's a real problem. Wireless smartphone charging too. There's all sorts of different schemes out there. Qi is one of them. Those aren't so bad because they don't charge at the 10 kilowatt level. They charge at maybe 100 milliwatts or something like that. So they're not usually, and like I said, anybody who's got a rechargeable toothbrush already has wireless charging in their house. And then the legalization of marijuana in many states, right? Grow light. What's going to happen is the grow lights are going to be imported as cheaply as possible. And, Connecticut, where I live, I think it's another year before we can grow it, but you can go and purchase it right now. So kind of glad I'm not in that job actually anymore. Some resources. These links should all still be good. David Cole, NK7Z. I worked with him a lot. He's a great guy. He used an SDR to kind of characterize the millions of thousands, he has on his website of different noises that you might see, things that are 20 kilohertz apart. Stuff that, here's your main things. Battery chargers from Harbor Freight, terrible. Really, I've got one on there. In fact, I've got a video on YouTube where I have this battery charger, plug it in, show the noise, then I take it apart, and I didn't take it apart previously, but I opened it up, and there's the circuit board with all the components missing that are supposed to be, because Ed wanted to sell that. Ed wanted to sell that battery charger a little cheaper. The board is all laid out for it, for all the filtering components, but they're not there. And then I put in my own, and you could see the difference. You could see the noise level go down. Electric bicycles are getting more popular. Electric golf carts are a real, a problem in some places. So really, you got to get knowledgeable on this. The RFI book, this is the 3rd edition. I think there's a 4th now that they sell. Shameless plug there. But I do have RFI videos on YouTube and a lot of other stuff. But I did quite a few series on battery charger, solar power noise, all that sort of stuff. So I think that's it. If there's any questions, I could answer them or try to.
I have one. From what you've learned, I mean, how empathetic, I don't know if that's the right word, are power companies if you approach them to say that you think that they have a problem, that type of thing?
Across the board, they're radically different. Some of them, okay, so you have big power companies like PG&E and Eversource and all, some of the larger ones. But then you also have co-ops like down south and some of the less populated areas where one case that I worked on, the power lines were arcing to the trees, and that's the only way they were able to get somebody out there to fix it. They were causing a horrendous noise as they were arcing, but then they finally caught on fire one day. So, and I was after that power company for quite a while. I wrote lots of letters to the power company. The FCC wrote letters. Some of them are fantastic. PG&E is getting better because they know that, you know, if they have a problem, that they cause another forest fire or wildfire out in California. So it varies. Around here, the Northeast or Eversource is pretty good. I've had a couple of problems. I knew a few people who work there. Having an in like that can sort of grease the wheels quite a bit. So it's kind of a crapshoot. Typically, the bigger ones are a lot better, but the smaller companies, you know, they have to call a guy from 200 miles away to come and look at this RFI problem. And then what if it's not happening that day because it happened to rain the night before? I don't hear anything, or they don't have equipment, or they don't have a knowledgeable tech. You know, they're really stretched thin in a lot of places.
Other questions?
Yeah, this is Charlie, AC2ZU. Paul,
Hi, Charlie.
how you doing, Paul?
I'm
I thank
doing all right.
thank you for all the help you gave to me. I'll tell the group. You did a great job for me. I have an SDR radio. I have the SDR radio, and you had told me to get use the SD card. I was able to record the noise, and you analyzed it for me, and it was a power line issue. It turns out I think the company has straightened everything out because they got new transformers up the street. I had gone with an AM radio up there, and I did notice there was some problems, but then it kind of went away. So the transformer looks like it's a new one. They probably replaced some insulators, but you did a great job in analyzing it for me. So the SDR radio with the SD card and the ICOM 7300 really works well to analyze it if you have one of those.
Again, this is no antenna, just the IF noise. And here's a typical RF problem coming from the power line. 122. This is a dead giveaway. Okay, doesn't tell you where it is, just tells you that it's a dead giveaway. 120, 240, 360, 480, 600. Thank you, Charlie.
Thank you for everything you've done.
Other questions? Yeah, Jim, you have a question.
Recently, I had the problem of RF coming in through all my radios. Curiously enough, when I had a disorganized mess on my desk, everything worked fine. I decided to put everything in order, stack it up, put it all together, a nice tight package. And when somebody started telling me that I was having problems, I looked at my desk and realized I had an HF radio, a VHF, a UHF radio, a SWR meter, a computer, some cooling fans.
Yeah.
All these things, nice, tightly compacted. So I did the trick, and I heard every word you said. Paid close attention about the toroids. But I went.
What antenna are you using, Jim?
I've got a coil for the HF. Put out and take in, and I have a Tram 1477 dual band for the UHF and VHF.
But you know, talking about RF for back into the shack like that, you know, if you ask an amateur radio operator, when he puts a dipole up, how many wires does he use? And that sounds like a really dumb question, but he's using two, but he really has three. And the first one is, let's say the center of the coax goes off to the left, the shield goes off to the right. But once the RF exits the coax cable, it also has the ability to come down the coax cable. So you have three different conductors. Several times guys would call up and say, you know, I put up a 40-meter dipole and it's 33 feet on the ends and it doesn't resonate. And I've been cutting and cutting and cutting and cutting. It's not making any difference. And I said, well, how are you feeding this? Do you have a small choke to stop that third wire from being in existence, right? Choking impedance right at the dipole itself. So if you don't do that, there's very good possibility RF could come back down in the shack. And it all depends on the coax length and stuff. Dr. Joel Hallis did a really good talk on this and why, you have a balanced antenna, the left and right sides of your dipole, with an unbalanced coax driving it. So you have the center conductor wire, the shield wire, and the coax acts as a radiator as well. So yeah, I could believe it. And by grounding everything together and getting, shortening up leads, if you have some RF in the shack, that certainly can make a difference.
I did place the toroids that I ordered, and that's like going to 7-Eleven. You get a dozen for a few dollars. For 10 cents more, you get 2 dozen, and then for 10 cents more, you get this great big bag that takes a 2-wheel dolly to move them around. So I immediately started slapping toroids on, and the next question was upstream or downstream. Do I put it next to the male plug? Do I put it next to the female plug? Do I put it to the back of the radio? Do I put it to the back of the power supply?
Well, let's talk about, again, what you're trying to do is you have a radio and you have one antenna, which is your coax, right?
Right.
You have another antenna connected to that, which is the microphone cable. You have another antenna, which is the USB cable going over to the computer, right? So where do you want to stop that RF? Do you want to put it at the microphone end, or do you want to put it right near the radio where it'll stop the RF from getting in the radio? You have to sort of look at all these things as transmitters, and I want to deprive them of antennas. Right?
Got it. Thank you. Answered my question right there. I appreciate it.
Yes, sir.
Perfect. Okay, so I'm looking at the clock. So anyone else with a question? Who wants the last word? Or else it's going to be mine. Paul, thank you so much for a great presentation. I know I've learned a ton tonight. Okay, and anytime I'll have interference in the shack, I know I've got my little checklist that I put together.